This resource is the first of a two-part series that considers graphing quadratic functions, which are called parabolas. Part 1 considers the methods for graphing parabolas. We look at graphing using a table of values with an example provided. We also consider various features of the parabola. We define how to use these features to form the parabola. Part 2 of the series looks more closely at using the features to create the graph of a parabola. We define how to find the values for the features based on the equation of the quadratic. We then work through two examples. A parabola is the graph for a quadratic function. Because it is a function, we can use the generic method for graphing functions. Use a table of values to find the coordinates for points on the graph. Pick appropriate values for the independent variable. Recall that the independent variable is usually x. Often, you will have these values provided for you. Plug the values into the formula. In other words, find the function value for each value. Solve. Find the actual function value. Plot your points. Each value of x paired with its function value provides the coordinates for a point on the graph. Connect your points. Note that the graph will not be a straight line. Also make sure to label your graph. Let's look at an example. Suppose we want to graph the function y equals x squared minus 6x plus 5. We need to select values of x to plug into the function. We choose the whole number values from 0 through 6. For each value, we plug that number in every time x appears. Finding the function value for x equals 0, we have 0 squared minus 6 times 0 plus 5, and so on for the other x values. Completing the calculations, we find that 0 has a function value of 5. 1 yields 0. The y value for 2 is negative 3. For 3 is negative 4. For 4 is negative 3. 5 is 0. And for 6 is 5. This means our graph contains the points 0, 5, 1, 0, 2, negative 3, 3, negative 4, 4, negative 3, 5, 0, and 6, 5. We plot each of these points. Connecting the points, we get a U-shaped graph that we label with the equation y equals x squared minus 6x plus 5. Let's inspect that graph and identify some features that may prove useful. The first thing we notice is that the U-shape is symmetrical. If we draw a line down the middle of the graph, both sides match up perfectly. This line is called the axis of symmetry. We also notice that there is a bottom point on the graph. This point is called the vertex and lies on the axis of symmetry. We also can identify where the graph crosses the y-axis. This y-intercept will also be useful. We can use these features to create the parabola. First, we find the axis of symmetry. This leads directly to finding the coordinates of the vertex. Then we find the y-intercept. To help flesh out the parabola, we will find another point on the graph. To finish the setup for the graph, we reflect the points we found over the axis of symmetry. This gives us a total of 5 points on the graph, so we can connect the points and label our graph. How exactly do we find these points? Stay tuned to part 2 of the series.